Hello everyone, good morning once again. My name is Sudhanshu Pandey and I am going to teach you today a very important topic of mathematics, and that is prime numbers. And why are they important? You know how many prime numbers are there from 1 to 100? There are exactly 25 prime numbers from 1 to 100, as you can see in this thumbnail. So they are 2, 3, 5, 7, 11, then 13, 17, 19, then 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 73, 79, 71, 83, 89, and 97. Now, you must remember these prime numbers from 1 to 100 and should be able to narrate them in just 15 seconds. Also, today we will do that challenge. And you should be in a position to write these prime numbers from 1 to 100. There are exactly 25 prime numbers in just not more than 30 seconds. If you do that, it will help you in the ratio and proportion, in fact in the rational numbers and in the fractions, in simplifying those with the divisibility rules as well. So today we will learn about prime numbers, but before that we must learn what are factors and multiples. In my previous videos I have taught you about the divisibility rule of 2, 3, 4, 5, 8, 9 and 11. If you are directly to this video, I want you to please go and check out those videos, because until you understand those topics, this topic will be a bit difficult for you. So I'm going to start with multiples and factors. You know what are multiples and factors? Suppose I write 4 into 3 is equal to 12. So I will say dear that this 12 is multiple of 4 and 3. I will also say not only this, I will also say that 4 and 3 are factors of 12. So when two and more numbers are multiplied, so the numbers which are multiplied are known as factors of the number which we get as a single product. For example, if I say, and that goes on with a large variety of numbers, not just for two numbers. So for example, if I want to say, I can say like that. I can generalize that. If A into B is equal to C, if A into B is equal to C, then we can say that, then we can say that A and B are what are they? They are factors of C. They are factors of what? Factors of, you can say, C. And you can say C is known as multiple of 2. Sorry, multiple of, so multiple of, we have got two numbers. What are they? A and B. See, whatever I'm writing, you must also write in your notebook. Please make a note of all these things. So two numbers which are multiplied together to form the third product, this product is known as a multiple, and the two numbers which are multiplied is known as a factor. I hope that you got that. Okay, fine. Now, the topic was started by saying what are prime numbers. So we must understand what are prime numbers, but before that I would like you to please pause this video right now and write the numbers from 1 to 100 in the same manner that I did. Write all the numbers from 1 to 100 in the same manner that I did. The numbers should align with the same row and column. See 1, 11, 21, 31, 41, it should be just below each other. Similarly 2, 12, 3, 13, 4, 14. Why I am saying so? Because now you will understand. Please first pause this video and please write down these numbers, and then again you can unpause the video, resume the video, and you can just learn with me. So now I am going to teach you the prime numbers from 1 to 100. We are going to learn the prime numbers from 1 to 100, and for that we are going to use the divisibility rule. We are going to use the divisibility rule now. So what are prime numbers? Basically, what is the definition of a prime number? So we can say that prime numbers are the numbers which have only two factors. Prime numbers are the numbers which have two factors. And what are the two factors? So we can say namely 1 and itself. You know, in mathematics we can say 1 is a factor of every number. 1 is a factor of every number. We can also say every number is a factor of itself. Now you must understand the logic that 1, by this definition, 1 is not a prime number. Most of the students get confused. 1 is also a prime number because one has got 1 in itself. See, you must have two factors at least. How many factors? I am saying that you must have two factors. Since 1 has only one factor, that is 1, and the itself number is also 1, so 1 is not a prime number. Neither it is a composite number. For the composite number, I will just elaborate those numbers in the next class with the prime factorization method as well, how to do the prime factorization. But first of all, we must learn what are prime numbers. So as I said that prime numbers are the numbers which have two factors, namely 1 and itself. So 1 is a factor of every number and every number is a factor of itself. So at least we have two factors for every number except 1. 1 is a special number. Let's leave that now. For now, let's leave that. So apart from 1, every number has minimum two factors. So that means if they don't have any other factor apart from 1 and itself, they will be known as prime numbers. Alright. So now we are going to learn the first 25 prime numbers from 1 to 100 in a very beautiful way. Now I might be closing all those numbers which are not prime, so that you can remember them. So 1 is not a prime number. So the first and the only even prime number is 2. Now 2 can only be divided. See, the greater number can be divided only by the smaller numbers. You must understand this. The greater number can only be divided by the smaller number or with equal to that number only. So the only number that 2 can be divided by is 1, and 2 is the only factor of itself. So there is no other factor. So 2 is the only, we can say 2 is the only even prime number. 2 is the only even prime numbers. All other numbers except 2 can be divided by 2 only. Can be divided by 2 only. So what we are going to do is, I am going to hide all those numbers which are below 2, and they will always be divisible by 2. They don't need any other number. Only 2 can divide them. In fact, only 2 is required to divide them. They can be divided by other number as well, but as far as 2 is concerned, 2 can divide all those numbers. So I want you to cancel all these numbers. In the meantime, you have written all these numbers. So please cancel all these numbers below 2 which can be divided by 2. Not only these numbers, you can cancel all those numbers which are ending with 4, because in the divisibility rule of 2 we have learned that these numbers which are ending with 2, 4, in fact 6 and 8 and 0, they can always be divisible by 2. So that means these numbers can never be a prime numbers. The number ending with 2, 4, 6, 8 or 0, they can never be a prime number. Apart from that, I can also say the number ending with 5 can never be a prime number apart from the first number, that is 5. Okay. Apart from 5, there is no other number which is ended by 5 and cannot be divided by 5. So those numbers can be divided by 5, so they can never be prime number. Apart from 1 and itself, they have a fixed factor known as 5. With the divisibility rule of 5, which I have already taught you, the number ending with 5 and 0 are always divisible by 5. So these numbers will be divisible by 5. So the numbers ending with 5 can never be prime number. So what are prime numbers then? Prime numbers are the numbers which can end with 1, they can end with 3, they can end with 7 and they can end with 9. Now out of those numbers, if you look at them carefully, 1 and 7 has a difference of 6. The number ending with 1 and the number ending with 7. See, 41 plus 6 is how much? 47. 21 plus 6 is how much? 27. 31 plus 6 is how much? 37. In fact, 33 plus 6 is how much? 39. So the number ending with 3 and the number ending with 9 has a difference of 6. The number ending with 1 and 7 has a difference of 6. The number ending with 3 and 9 has a difference of 6. So if one of the number is divisible by 3, then its counterpart, that is 6 added to that number, will also be divisible by 3. If one of the number is not divisible by 3, then its counterpart 6. That means if 31 is not divided, 37 is also not divided. So you just need to remember one number, either it should end with 1 or 3. If it is ending with 1, it will also end with 7. If it ends with 3, it will also end with 9. That's it. In the first row, this is row. In the first row, you have got 4 prime numbers. How many prime numbers? 4 prime numbers. So 9 is not a prime number because it is divisible by 3. Now we will be hiding all those numbers which are divisible by 3. See what we have done? We have hidden the number which are divisible by 2 and 5 as of now. Now we will be hiding the numbers which are divisible by 3, and I taught you in the divisibility rule of 3 that the total sum of the numbers should be 3, 6 and 9. So let us check in the second row. In the second row we don't have any other number. See, 1 plus 3 is 4. So 11 and 17 both are not divided, 13 and 19 both are not divided. Now see, 2 plus 1 is how much? 3. So if 21 is divided, it is but obvious that 27 will also get divided. So 27 means 2 plus 7 is 9. 2 plus 7 is 9, so it is also divided. Similarly, 3 and 3 can be divided. So that means 33 is divided, so its counterpart 39 will also be divided. Similarly, you can see 41, 4 plus 1 is 5, 4 plus 3 is 7, 4 plus 7 is 11, it is not divided, 4 plus 9 is 13. So all the 4 numbers are not divided by 3. Coming to the next row. So you can say 51 is divided by 3 because 5 plus 1 is 6. So if 51 is divided, 57 will also be divided because 5 plus 7 is 12. Similarly, you can say that 63 is also divided. 6 plus 3 is 9. So 69 will also divided. No need to add them because the last digit is 6 and 9. So if the digits is 6 and 9, you don't need to add them. They will simply be divided by 3. Similarly, in the case of 71, 7 plus 1 is 8, 7 plus 3 is 10, 7 plus 7 is 14, 7 plus 9 is 16. So none of the number is divisible by 3. Coming to the next part, so 81, you can see 8 plus 1 is 9, it is divided, so 81 is divided, so 87 will also be divided. I told you already, the number ending with 1 and 7 will have the same kind of issue. Now in the last case, you can see 93 can be divided, in fact 99 can be divided. So we have checked the divisibility rule of 2, 3 and 5. And you know what? 7 does not have any divisibility rule. So now we have to check with 7 as well. We have to check with 7 as well, and we have to check all the numbers now. So 7 is the only, you can say 7 is a prime number. So in this row, you know the table of 7 up to 70. Let us check it. 7 into 2 is 14. Now here 7 into 3 is 21. 7 into 4 is 28. 7 into 5 is 35. 7 into 6 is 42 is not here. 7 into 7 is 49. So we have to check only with odd numbers. So 7 into 7 is 49. So it is divided by 7. 7 into 9 is 63. No needed. 7 into 10 is 70. 7 into 11 is 77. So 7 into 11 is 77. It is divided by 7. And 7 into 13 is 91. So 3 numbers with 7. 3 numbers are 49, 77 and 91. Now the leftover numbers are the prime numbers. And you know what? How many are they? I told you 25 prime numbers. So we will get the first 4 numbers from the first row, 2, 3, 5, 7. The second row also has 4 numbers, 11, 13, 17 and 19. Now every row will have just 2 numbers apart from the row of 40 and 70. The row of 40 and 70 has 3 numbers. Every other row has just 2 numbers. So the 2 numbers are in this row is 23 and 29. It is but obvious it will be shifted to 31 and 37 in the next row. Again in the next row it will have 3 numbers, 41, 43, 47. In the next row it will be 53 and 59. Then again it will become 61 and 67. And then you will have again 3 numbers. So I must write the numbers in the way so that it is written in the front of their row as well. So 11, 13, 17, 19. Then you have 23 and 29. Then you have 31 and 37. Then you have 41, 43, then 47. Then you have 53 and 59. Then you have 61 and 67. Then you have 71, 73, 79. Then you have 83 and 89. Then you have 97, the only single digit prime number in the last row. So if you count, how many are there? So let us count. So 4 plus 4, 8 plus 2, 10. 10 plus 2, 12. 12 plus 3, 15. So up to 50 we have how many prime numbers? 15. Then from 50 to 100 we have 10 prime numbers. So 2 plus 2, 4 plus 3, 7 plus 2, 9 plus 1, 10. So 10 and 15. How many are total? Total there are 25 prime numbers. And you should be in a position to remember all these 25 prime numbers. If you want to say it orally, just have a checklist of with the timer. So let us do now. Let us check with the timer. So first I am going to narrate and then I am going to write. I am going to narrate and write, both together I will do, and I will try to do it in 30 seconds. I want you to practice this in 30 seconds or in 45 seconds, but not more than that. So I am writing in front of you, you should do with me. You can pause the video, you can just learn it and you can just practice of your own, or you can do with me. So the numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89 and 97. See, I just took 27 seconds to write all these numbers. And you can check my handwriting also. I think all the numbers are crystal clear in front of you. The board was a bit shorter for me, or if I would have written like this, I could have done it in a much better timings. Let us check once again. So I'm writing horizontally 2, 3, 5, 7, 11, 13, 17, 19. Then we have 23, 29. Then we have 31, 37. Then we have 41, 43, 47. Then we have 53, 59. Then we have 61 and 67. Then we have 71, 73, 79. Then we have 83, 89. Then we have 97. Again the timing is same. So in just 30 seconds I am able to do this, and if I want to narrate this, you can just check the timing once again. I will narrate these numbers in just 12 seconds. You can 12 or 15 seconds, not more than that. You can check with all the numbers I am going to narrate in front of you now. So the numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89 and 97. Yeah, it took just 13 seconds. You should be that fast. And if you are that fast, you can quickly understand, oh, okay, this number has to be written in the simplest form. So if in front of you the number is given like 51 by 68, you will think, okay, 5 plus 1 is 6. These are the composite numbers, so they can be divided. And you can use the divisibility rule. Okay, 17 into 3, 17 into 4. So the final answer is 3 by 4. You must remember the prime numbers, the first 25 prime numbers. With this, I'm going to end this session now. And I think that you have liked this session. And please do give rating. Please rate me on the basis of 5 so that I can learn more. And if you have any doubt, you can just ask me. And with this, I'm going to end this class. Please have a great day. Take care of yourself. Bye bye. Take care.